Hello everyone! In today's video, we are going to talk about the IPFS and the revolution it offers in our relationship with the Internet. Imagine a huge collaborative library whose books are unique, permanent and irreplaceable, in which we can search anonymously and very quickly for the content we are interested in, and in a secure way. A library that would never close, that could welcome countless visitors without ever saturating, and that would not fear censorship nor fire. That is pretty much what IPFS is all about. The IPFS protocol for interplanetary file system was designed by Juan Bennett in 2015. It aims to revolutionize the Internet as it is today. Benjamin Bayard said in 2007 that the Internet has turned into a kind of Minitel 2.0. When we use the Internet, we search for information on a central server which provides us with this information in a similar way to that of the Minitel. But the idea of the Internet was to connect all users, to make each of them both a sender and a receiver with no central point. This may remind you of peer-to-peer systems, where nodes function as both clients and senders. The centralization of the Internet. The Internet has become a necessity in our lives, whether it's for researching, shopping, paying bills, communicating, or viewing, posting and sharing content. Beyond our daily uses, it is probably our most valuable technology. The initial idea was to set up a sustainable network, one in which everyone is equal, a network of peers. But the quest for performance and the competition from businesses resulted in monopolies, in giants such as GAFAM, that shaped the Internet to its current state. However, this centralized model shows limits today more than ever, such as data security, accessibility, network efficiency, information persistence. Towards an interplanetary file system. So we need an alternative, and IPFS presents itself as the solution to solve these problems and return to the original goals of a distributed Internet. What would this look like? To answer this question, let's take a look at three file system models. The first one is centralized. It's the Internet as we know it. The centralized Internet suffers from many weaknesses, since it is built around central authorities that concentrate a significant amount of power over the network and are not foolproof. The centralized Internet is an Internet with large data centers where all the information is stored. By contrast, in the decentralized Internet, there are multiple centers that are connected to each other. We still rely on centers, but there are significantly more than in the centralized model. It is halfway between the centralized Internet and the distributed Internet, which is our alternative. In this distributed Internet, all the centers that store data are removed and replaced by users. All users are nodes on the network, and all nodes contain a part of the information. This is what IPFS offers. It consists in building a distributed system where everyone participates to the network. Ultimately, it is a coordination of individual efforts that prevents breakdowns, monopolies, and censorship that are real issues with the current model. For example, in April 2017 in Turkey, the government decided to block access to Wikipedia. Soon after that, a copy of the site was put online using the IPFS protocol, a version that the Turkish government couldn't block because it was distributed. Indeed, the content of the site was not hosted and retrieved at a specific location. Instead, it was retrieved directly from the content itself. But what does that mean exactly? Location-based addressing versus content-based addressing. There are two different types of systems. The IPFS system does not ask us where to look for information, but what information to look for. Let's compare them here in a few words. A way to proceed is called location-based addressing. For example, URL, what we usually call a web address, such as this one. In this example, we are looking at a specific location in a tree view for the file illustration 3.1 in order to display it. With the IPFS protocol, it works in a different way that is called content-based addressing. Here we see a unique hash that allows access to the content without knowing its location. Within this content, we find the file, illustration 3.1, that we are looking for. Additionally, the hash code guarantees the integrity of the data returned to us. This is not possible with location-based addressing. The content may have been edited, sometimes maliciously, which raises security issues. It may even have completely disappeared or moved if the address has changed or if the site has been shut down. This is especially relevant when you consider the average lifespan of a website, which is less than 3 years, or the risks of accidents and other natural disasters. Like on March 10, 2021, in France, when a fire in a data center impacted 3.6 million websites that went offline. Despite backup measures, many websites were forever lost. With IPFS, since data is no longer located at a specific place, but at many places, its location does not matter, since we search directly for the content itself. This provides the means to create an internet that can no longer be disconnected. But there is more. Network optimization. Indeed, and as mentioned earlier, the IPFS protocol seeks to revolutionize the internet in its very structure, and so it also provides answers when it comes to improving the network. The centralized internet suffers more and more from network congestion that degrades the services. Internet traffic is increasing. Just think of video streaming, which is becoming more and more popular. In March 2020, content broadcasting services such as Netflix or YouTube announced they would temporarily reduce the quality of their videos in Europe in order to avoid network saturation. IPFS addresses these problems by multiplying the sources and getting the information as close to you as possible and as fast as possible. While this all sounds very promising for the future of Internet, there are still a few problems. Limitations of IPFS. The main issue is that it needs to be massively adopted in order to show its full potential. As mentioned before, distributing the web implies that each user becomes a node of the network in the same way as for peer-to-peer protocols. And as such, if there is no seeder, there is no content. This is why a solution has been developed known as IPFS clusters. The IPFS cluster service complements the system. It allows content to be replicated and pinned, therefore indicating that this content is important and must be kept on a network of IPFS nodes. It is indeed essential to ensure that the content is online at all times. This means that a central authority, that could be anyone, has the power to decide that a specific content should be pinned. Pinned content will then be kept no matter what by the network nodes, thus ensuring that this content is always available. IPFS in practice. As we saw earlier, content-based addressing on the IPFS is done through hashing. Let's take a closer look at this process. For instance, a user wants to share a file on an IPFS server. To achieve this, the file will be split into several files, also called blocks, of a certain size, usually 256 kilobytes. The number of blocks thus depends on the size of the file. Because of their small size, these blocks can be more easily replicated on the network and therefore more easily distributed. This is crucial in the IPFS system to save and access content. This ensures that access to this file will always be possible and the pieces of this file will be present everywhere. Each of these blocks is identified by the hash matching its content. The hashes of these blocks will then be combined in pairs and themselves hashed until only one hash is obtained, the root hash, also called CID, content identifier. Through a system of identification and links between the blocks, the CID allows access to all the blocks that are recombined in order to reconstruct the original file. This is called DAG, or Directed Acyclic Graphs. Juan Bennett uses the expression Merkle DAGs to describe this structure. This hash system also guarantees data integrity. If a single block of data is corrupted or modified, its hash will change as well as those of its parents up to the root hash. The tamper-proof quality of the files is thus guaranteed. That's all. I hope you now have a better understanding of why IPFS will be like the collaborative library we talked about at the beginning of this video. Opening the web, distributing it, making it more and more efficient and open source is a major challenge for the future. It also means regaining control of our data and our personal data that we lost to GAFAM.